Okay, so we're going to be looking at central angles and arcs today. So a central angle in a circle, so if we have a circle and we have some kind of center in the middle, we'll call A. A central angle is just going to be an angle that basically starts at the center and ends on the outskirts of the circle. So like points, angle A, B, and C here would be central. So a formal definition would say a central angle has the center of the circle as its vertex. So the vertex is at the center, and the sides contain 2 points of the circle. In our example above, the vertex is at A, and then the 2 points on the circle are A and B. So what we'll be talking about a lot in this section is what's called an arc. Now an arc is just kind of part of the outside of the circle. For example, BC here is an arc, and we simply denote that as 2 letters with a little half, like kind of arc above it. So that is BC, arc BC. So we actually will measure arcs in degrees a lot of the time. So we could say an arc is 30 degrees or 40 degrees or 50 degrees. So one kind of arc we have is what's called a minor arc. Now a minor arc is when you have a smaller arc, and we define it as the arc degree measure of any arc is equal to the measure of the central angle. So whatever this central angle measures, so say it's 45 degrees, then we say the same measure for the arc. And a minor arc is always going to be less than 180 degrees. So if we look at this example, we have this central angle ABC, and it is 110 degrees, and the arc it cuts out would be this arc right here. So we can say the measure of arc AC, which in this case is that arc cut out by 110, is simply 110, because the measure of the central angle is the same measure as the arc. Now if I put 2 other points on here, let's call this D and C. And let's say I know the measure of arc DC is 30 degrees. Well, in a reverse kind of thing, well, we could say, well, then the measure of angle DBC is also 30 degrees. So if you know the arc, you know the central angle, or if you know the central angle, you know the arc. All right, so the last thing we have, the other kind of arc we have is what's called a major arc. Now a major arc is going to be basically an arc that's going to be larger than 360, or larger than 180. So if you think about our circle example up here, this would be the major arc. It just basically goes the other direction. So a major arc is an arc degree measure that equals 360 minus 360, because all circles are 360, minus the measure of the minor arc, and is greater than 180. It's going to be bigger than 180. So if we look at this example here, if I want to know this major arc, let's say I want to know how big this arc is here. Well, I couldn't say arc E and D, because if I say arc E and D, then that's really referring to this smaller arc here. And we know the measure of arc ED would just be 60, because that's the central angle. So if I want to refer to the bigger arc, I would use 3 letters, so maybe D, F, and E. So I could say the measure of arc DFE, which is that bigger one, is 360 minus the minor arc, which is 300 degrees. So both the major and the minor arcs have to equal 180, or 360, pardon me. So the minor is less than 180, the major is more than 180. So we have greater than 180 or less than 180. So we also have, when it's equal to 180, we call that a semicircle. So an arc degree measure that equals a semicircle equals 180. Or which is just simply a semicircle. So in this example, I could say the arc MKL, which is this arc on that's going to be 180 degrees. At the same time, I also know the arc the other direction, which is also a semicircle, JML, will also equal 180 degrees. So here's a couple quick examples. Which arc is made by the central angle below? So we have QPR, which is this angle here. So the arc it cuts out would simply be RQ. So the measure of this and the measure of this would be equal. So you just kind of extend the sides of the angle to get the arc. Same idea here. It says name the central angle of the given arc. So we have KM. So KM is this one. I know it's the small one because I didn't include this N over here. So the angle that cuts that out would be angle MHK. So the angle cuts out the arc, or the arc is part of the angle. So really knowing that the central angle of a circle is the same as the minor arc intercepts, we can really find a lot of different measures of arcs and angles in any kind of given circle. So here I just have four kind of mixed examples of kind of problems that we can work through to try to see what some arcs and angle measures are. So this first problem, it says find the missing angle or arc measure. And it says the measure of angle NKO, which would be here, is 100. So this angle is 100 degrees. And we want to find the measure of arc NMO. NMO. So NMO would be this big arc that goes all the way around here. Now I know that since the central angle, NKO, cuts off an arc, it cuts off arc NO. So the measure of arc NO would be 100 degrees. That's the minor arc cut off by those two. Now the big arc, NMO, is not 100 degrees, but it is a major arc that's the other part of NO. So we can simply say that arc NMO, which is this major arc, is 360, which is the whole circle, minus 100 degrees, which is that minor arc. So then 360 minus 100 would be 260 degrees. So again, it's just kind of playing with the circle, looking what you have for each one. Let's look at this one over here, where we have all these different angles. We have E in the center, we have F, G, H, and K, and the goal is to only find arc GF, which is this arc right here. Now what it tells us, it tells the measure of angle GEF is 105. So this angle right here is 105. But since that's the central angle that cuts off minor arc GF, GF is just also 105. Because we said whatever your central angle is, whatever arc that cuts out would have the same measure as the central angle. Okay, let's look at a couple more down here. So here we have a bunch of information, so let's start writing it in. So it says arc KH is 100. So KH is this arc being 100. Okay, so that arc is 100 degrees. And arc MN is 92, so this arc down here is 92 degrees. Again, just given information. Arc HM is 120 degrees, so that's this guy here. And it says arc NGH. So NGH, I'm sorry, angle NGH, which is this angle here, is 5x plus 3. And we basically want to find x. Okay? So if I look at angle NGH, that's the central angle. It looks like this. So really what we need to know is we need to know how long the arc NKN is. And we know part of it is 100, but we don't know the other part. Well, I can find this little part of the arc because I know the whole circle is 360, and I know every other arc. So if I take 360, subtract the 100, which is KN, and subtract the 120, and subtract the 92, that will give me what arc KN measures. So that gives me 48. So this arc here is 48. So now if I think of the arc that cuts out that central angle, it's 148, so it would be 148. So I know the central angle, 5x plus 3, which is for that angle NGH, has to be the same as the arc measure, which is 148. So I found the arc measure, and then I know the angle equal to that, and I can solve for x. So I'll subtract 3. So 5x equals 145, and then I'll divide by 5. So 145 divided by 5 would give me 29. So x is 29. Okay, let's look at our last problem here. So it says arc FE is 120, so FE is here. So that's 120. It says FDE, angle FDE is 8x, which would be this angle in here. Now this is a pretty simple one. Because this angle cuts out these arc, we know the measure of the angle must be the same as the arc. So I would just simply set these equal. So 8x equals 120. So to solve for x, I would just simply divide by 8. So I take 120 and I divide it by 8 and I get 15. So x is 15. Alright, so hopefully this was okay. Our first foray into arc measure. Please let us know if you have any questions.